So there is the new switch. Get some lights here. The new sensor, and it had 5 terminals in there, as you can see. It's linear, so as the selector shaft inside turns, it pushes up on this switch assembly, and it looks like it's held on with one retaining screw here and one at the back here. So we'll have a look at the vehicle and install it and see how it works. So there are 2 little T20 retaining screws, the head is T20 anyways, that hold this switch sensor in place in the transmission. But note to self, be prepared for the transmission fluid that's going to come out when you pull the switch out. The transmission oil was over full on this thing, but I think still you'd get transmission fluid out of there. I never thought of it, and so I got a little bath here. Oh well, we'll top up the fluid when we're done. Okay, so I got the sensor reinstalled, 2 screws reinstalled. It helps if you put the transmission in low range or in low gear, because the plunger is fully extended in low and fully compressed in park, so you'll be working against that spring-loaded switch in pushing it in if it's in park. And well, it's all reconnected, so let's see if it fixes it. So there's the manual shifter in park, reverse, neutral, drive, second, first. Remember before it didn't even indicate first gear when it was in first gear. So we're going to graph the data there on the instrument cluster as well with the scan tool. So I'm looking at a data list in the instrument cluster now. In the top right hand corner is the Prundle voltage created by that stepped resistor. Now it looks like it's changing here, but that's 4.08 to 4.1, so it's 0.02 volts it's fluctuating. So as I go through the shift points from park, reverse, neutral, drive, second and first, and then back again, we should see the step voltage there. I'm going to go in the vehicle and do that. And there's reverse, neutral, drive, second, and first. Second, drive, neutral, reverse, and park. That's drive. Wiggling the shifter doesn't seem to make it change. Well, I guess the moment of truth is to see if it actually fixes the random shifting. Like I said in the previous video, this shift indicator is strictly an input to the instrument cluster and theoretically should not affect the transmission shift points. But again, the instrument cluster is networked to the PCM, so who knows what kind of hocus pocus is going on behind the scenes. It appeared that when I was road testing this, every time the shift indicator on the dash said it was in second gear, it downshifted to second gear. Yet theory of operation doesn't state it works that way. I'm going to burn this truck driving at 85 kilometers an hour with the gear shifter in drive, yet the shift indicator on the dash indicates second, and it is in third gear on the scan tool. I don't get it. This doesn't make sense. Don't get it. Worked good for about 8 kilometers, and then all of a sudden it's stuck in third gear now. Yes, third gear. And of course no lockup. So I shifted the transmission into neutral and then back to drive, and it's okay again. graphing the park reverse neutral drive voltage signal, and it's in drive right now, and according to the instrument cluster it shows drive, but the voltage keeps dropping down. It drops down to about 1.3 and then it'll switch to second gear. Here's second gear commanded, 1 volt, go back to drive, and it's 1.6, 1.7. But there's got to be a short in the wiring harness that's pulling the voltage down, so it's thinking that it's going into a... And why is it jumping around like that? It wasn't doing that before. There's neutral. Even neutral. It's not indicating neutral in the dash now again. And the voltage isn't agreeing with it. Now it's indicating neutral. 2.2 volts. There's drive. 1.6, 1.7. So I'm going to have to check the wiring harness. I think what I'm going to do is graph this voltage and wiggle and move the wiring harness above the transmission. In the previous one, I looked at the electrical circuit and it was showing a connector over by the right fender. I didn't ever find that connector. It might be under the air cleaner box, so I might go look for that connector, see if there's corrosion in it or something. Something's pulling this voltage down. And we got the ABS and brake warning light back on. Oh joy. So I had driven the truck into town, which is about 30 kilometers, and I stopped at a parts store and decided I would try an experiment. I pulled these two fuses, fuse 18 and 22, out of the totally integrated power module, which are the battery fuses to the instrument cluster, figuring I would kill the instrument cluster and then see how the transmission functioned, because that should theoretically take it off the network. Well, removing both of those two fuses, unless they're incorrectly labeled here, had no effect on the instrument cluster. It still communicated and it still output voltage. Now the other strange thing is I shut the vehicle off, restarted it, and on the restart the check engine light came on. I haven't scanned to see why yet, but I just drove it 35 kilometers back from town and the Prundle voltage hasn't changed, didn't drop, didn't glitch. There's neutral, there's reverse, there's park, reverse, neutral, drive, and the voltage is 1.84 volts, bang on, all the way. It never skipped a beat, all the way back to the shop here. There's second, 1.2, and of course low is about 0.6. So the only thing I did was put those two fuses in and open and close the hood. I think I'm going to stop at the local church here and see if the priest is in. He can perform an exorcism on this thing. I'm going to shut it off and restart it again, just for the hell of it, to see if that check engine light has anything to do with this scenario now. Oops, I've got to put it in park to start it. Check engine light is still on. Well, we'll go for another small road test and bring it back to the shop again. So I've got the instrument cluster partially out. Got the key on. Gear shifter in drive. And the ignition is on and it's indicating drive. Come on. But you can see the voltage fluctuating here. And if I wiggle the connections on the back of the instrument cluster, which I'm doing now, and I'm not sure which connector it is, there appears to be 3 of them. The instrument cluster is pretty warm, but if I tap on it, it's not going to act up now. But prior, when I tapped on it, the voltage started to drop down to about 1.4. Well, I'm gonna have to get this out of here, and I'm not moving any wires. The truck's not running, so I can't see it being under the hood. Manipulating these wires on the back of the instrument cluster, manipulating the instrument cluster in general seems to make a difference. So the 5-volt supply is from connector 3, pin 10, and the actual signal voltage is connector 2, pin 14. I've got connector 2 unplugged right now. There's pin 14, that's the green yellow wire, and with it unplugged it shows 5 volts, which makes sense. It's an open circuit. So we're going to look at the pin grip on that particular pin. That's the second pin from the bottom there. I'll try plugging it in and seeing if the voltage will change. We'll read the voltage on the back of the pin. So this schematic shows connector 3, pin 10, yellow tan wire as the 5-volt supply, and connector 2, pin 14, dark green and yellow wire as the signal. Well, if I go to connector 3, pin 10, which is this pin right here, yellow and tan, and back pin it, I have no voltage on that wire. Yet I have 5 volts on this wire if it's disconnected, and if it's going through the transmission range sensor, it drops based on the resistance. So I think the schematic is wrong. Imagine that. But I also noticed that if I manipulate this return wire, this yellow wire here, you can see a change in the voltage. Well, it's not doing it as much as it was. I've unplugged and plugged the connector in 6 times now. Okay. So there I'm backpinning the signal wire, the green and yellow trace wire, and I'm going to manipulate this other circuit. I'm just pulling the terminal up and down, and it's affecting it, and it's showing up on the scan data as well. Oh boy. So it might be a cracked printed circuit. Remember, this instrument cluster has been replaced with a used one, which is not actually correct for the truck. That's why it's got the service 4-wheel drive message. So, took the connector apart, got a piercing probe attached to the wire so that I'm not mistaking my connection for being intermittent. But even after taking that terminal apart and cleaning it and checking the pin grip, if I tap on this, I can occasionally get it to drop out. And it's getting better as I think the instrument cluster is cooling off. That other tan beige wire, if I manipulate it, I can make the voltage change a little bit, but not significantly. I think the problem's in the printed circuit. I think there's a cracked trace in there that's causing the problem. I think I'm going to disable the instrument cluster so that we have no information from the instrument clusters about what gear it's in, and then go for a road test and see if the transmission still malfunctions. See how it shifts with no data from the instrument cluster. That'll be interesting. So the truck wouldn't start without the instrument cluster plugged in, wouldn't crank. So I've reconnected connectors 1 and 3, left connector 2 unplugged. That's the one with the transmission range sensor signal, so you can see the Prundle is blank. And we're going to go for a road test and see if this transmission still acts up. So I just drove this truck for about 20 kilometers at highway speeds, and the transmission worked flawlessly with the instrument cluster connector 2 unplugged. Shifts through all gears properly, no hunting, no downshifting. Works the way it's supposed to. So I'm going to reconnect that connector and restart the vehicle and see if it will malfunction again. So I've got the connector plugged back in again. Transmission's in drive. Indicator on the dash shows drive. So we're going to go for another road test and see if it will malfunction. So it did it again finally after about 10 kilometers of driving, and you can see the range selector voltage dip down to about 1.2 volts, and that's when it showed second gear on the instrument cluster and the transmission downshift when it did that. Let's go back into a live recording. Right now we're sitting at 1.8 volts, and if I manipulate the dash, I can't get it to go that low, but I can get it to change there. So I think there's a problem with this instrument cluster. Man, I think when it gets hot, the 5-volt reference supplying the 5 volts to that sensor, I'm moving the wires on the back of the instrument cluster. I can't get it to go low enough to indicate. Okay, I'm going to stop moving the wires, put the instrument cluster back into its spot. Or is it coincidental? Oh, what to do? If I had another instrument cluster, I would just plug it in, but I don't. Well, I guess that's what we're going to have to try to find, see if somebody's got one. I'm holding the instrument cluster connector, and it cleans right up at 1.88 volts. And yet, when I let go of it, it spikes back down. So I'm 99% sure there's a cracked printed circuit in here. Let's pull on the connector again. There we go. I just checked with the local wrecking yard, and apparently there's nothing locally available for this thing. So I'm going to have to discuss this repair with this customer. I have a couple of ideas. So in the electrical schematic, it showed connector 131 as being over by the right fender, but then it was a gas engine. And this is connector 131, which in a 2005 model is labeled 132. I've got it disconnected, and the Prundle voltage goes to 5 volts because that green wire must go through that connector, and if you open the circuit. Now, I had it connected and wiggled the connections, or wiggled the wiring harness out here, and nothing changed. Oh, okay, good to know. So here's the theory of operation of that transmission range sensor according to no data, I mean all data. 3 primary functions: park neutral, start the engine controller, starter relay, backup lights, and provide transmission range signal to the instrument cluster. But down here under operation, it says as the switch moves through its linear motion, contacts slide across the circuit board, which changes the resistance between the range sensing pins of the switch. Power supply on the instrument cluster provides a regulated voltage signal to the switch. The return signal is decoded by the cluster, which controls the Prundle, and corresponding with the correct transmission range. A bus message of transmission range is also sent to the cluster. Read between the lines. What does it do? What do the other computers in the system do with that bus message? In reverse range, a second contact set closes and circuit providing power to the reverse lights. So I think I've found a possible replacement used instrument cluster to try on this on Monday. But in the meantime, I think I'm going to disable that one wire. So I'm going to put it on a toggle switch so I can temporarily turn that on and off while it's acting up. The trouble is this condition is so damn intermittent. Sometimes you can drive for 5-10 kilometers before it starts to act up. I'd like to be able to switch the signal off and see if it instantly corrects the problem. I'm 99% sure that the instrument cluster 5-volt reference is breaking down because of a bad printed circuit, but without changing it out, I don't know what else to try. So I put the dash back in, and I wired a toggle switch in that circuit so I can turn that circuit all open at will without having to do anything other than flick a switch. But now I got to sit here running and idling, and just watching the voltage in the park, and all of a sudden it started to change all by itself. And then I smacked the top of the dash, and it went back to normal again. Let's see what it's at now. Seems pretty
reasonable now. But I think that circuit board is failing in there. But I'm going to take it for a road test with the toggle switch in it. When it starts to screw up, I'll turn the toggle switch off, opening up that circuit so we have no trundle indication, and see if the transmission stops doing its hocus pocus. So I took it for a road test, drove it about almost 10 kilometers before it started to act up again. Watching the system voltage here. Right now I got it on full graph screen. It's running at about 1.5, 1.6 volts. And it's indicating that it's in drive. I put a toggle switch to interrupt the circuit in here, and it's on right now, so it's using the circuit. Watch what happens when I hit the dash. Why do the wipers come on? That's strange. Anyways, if I turn that switch off while it's doing its hocus pocus, and of course when I turn the switch off, the signal voltage will go to 5 volts. The indicator disappears completely. The transmission stops hunting through shifts. So obviously that input to the ECM is affecting the transmission shifts. And as far as I can tell, it's the instrument cluster that's causing the issue. Sitting here idling in the gear, and the gear shift indicator has disappeared and occasionally shows neutral, and it's in park. Obviously there's reverse, there's park. It's acting up again, showing drive second, and you can see the system voltage changing. I wonder if I can simulate that resistance with a variable resistor. Now that I've got this toggle switch here, I should be able to just open that toggle switch, put a variable resistor in there, and dial up a resistance value that would equate to drive. So I got a resistor box wired in here, simulating the voltage drop. 1.7, 1.8 volts. Makes the gear shift indicator show drive, even though it's in park. Just a thought. And the voltage is still fluctuating, so it's definitely not wiring, as I'm actually bypassing all of the wiring with this resistor box. If I tap on the dash, I can get the voltage to change. So let's see if we can find an instrument cluster for this thing.